Hello and good evening. Welcome to this webinar with the IET as well. So it's a joint venture, this, isn't it? So you've got myself, Darren Staniforth, Mark Coles and Dave Austin. We're going to be looking at those changes that are going to be affecting us and how they're going to be affecting us as well. So tonight is the time, isn't it? So
it's the big midnight.
It's
the big
midnight.
switch,
it's midnight. Is the switch over, isn't it? So we're going to be looking at that.
What we thought we'd do, because there's been a load of stuff out there, we've been doing it, where you actually go through the specific regs and how they're changing. But what we thought we'd do is take a little while to look at the big ones and the changes that will really need to be made by everybody out there working as of tomorrow when Amendment 2 becomes fully operational. So that's a relaxed hour-ish with you, and if you've got any questions at all, start firing them in. We've got teams of people here waiting to receive your questions. They will then be beamed to my phone here, and we'll be trying to answer every question we get over the course of the next hour. So do please send us your questions, but we're going to crack on straight through and look at some of the key points we think need to be talked about.
Yeah, Mark's going to really help us here. So Mark's going to take a lot of the heavyweight stuff off of us, aren't you?
That just knows so much, doesn't it? It's all hidden inside that curly, lovely curliness.
Yeah, so we're going to start going through this. So the first thing we really need to look at here is how the introduction is going to affect us. You've probably heard a little bit about this, and this is because there's been a new phrase introduced into this part of the regulations. Yeah. It may have existed elsewhere, but this is where a new part has existed, and that new part existing is the word withdrawn. And that withdrawn part, Mark, is the bit that is going to stop some things happening tomorrow morning, isn't it?
This is the key thing. This is the first time that withdrawal has been used in BS 7671, and it aligns with other British standards because they all have withdrawal in them. Now, BS 7671 didn't, but a bit of history. This concept of the 6-month period where the old is phased out and the new is brought in, that came about in 1981 with the 15th edition. And the concept is that there's time for people to retrain, there's time for courses to get up to speed, to get the information in there, and also for manufacturers to get their products on the shelves too. So that came in 1981 with the 15th edition. It's been there, 41 years?
I'll take your word for it. I
41
remember that far back, mate.
Well, we've got used to it, haven't we? We've got used to this idea that 6 months from now, the old one will go away and the new one will come in. So what's the subtle difference then with the withdrawn thing? Is that the standard doesn't exist anymore?
That's right. It will exist. It'll be there if you need it. For instance, if you're doing some kind of work where you're looking into the past to see what happened at a particular time, you might need it for a court case, something like that. Mm-hmm. So the information will be there for you to use. But from midnight tonight, you should not be using the previous version. So it's a blue book, and Amendment 1, of course, was just the paper-based, Section 722. Yeah. So the two together formed the then current version. Right now, there's 2 current versions, but after midnight, it's just solely the brown book that you'll work to.
So any jobs then that are going to bridge over that, can they carry the design over, or does that mean halfway through a job I have to switch all of a sudden then to switch the design and the installation over to looking at the brown book, even though we're halfway through it?
Ultimately, when you complete a job, you'll sign it off on that day to the version that is current on that day. So after midnight tonight, you will sign off to the brown book only. Even though your job might have started today, if you finish tomorrow or next week or even next year, that's the version that you will sign it off to.
So that's signing off, but let's just clarify, because Mr. Haroon has said he's recently done his 18th edition, must be quite cross now. Does that mean I need to redo it to the new amendment to carry out work? And of course it doesn't, but what is the situation with qualification?
The situation with qualifications is, the bottom line is you've got to be competent. So your scheme provider, for instance, will have requirements. When they come to assess you, you'll need to be up to speed. That's the bottom line. I think what they're saying is, and IT is not a scheme provider, but the scheme providers would want you to have the 18th edition and then, of course, be up to speed with the amendments.
So, answering Mr. Haroon specifically, but actually anybody, if you are part of a scheme and you need to be inspected, they will be asking you questions about the current edition, which will be the second amendment. So if you haven't trained on the Brown Book and you don't know much about Part 8, they will be asking you questions about Part 8 in your assessment. So it's important that you get up to speed on that, even if you don't carry the piece of paper that says you've passed the exam. That would be a fair assessment, wouldn't it?
Yeah, absolutely fine. Now, coming from a background of scheme providers, as I did for a number of years, we can see that there are some periods where we all need to retrain. Now, this isn't one of them. That's normally when the regulations change completely. So we go, for instance, from the 18th to the 19th, that's when we'd all have to go through those major changes. But scheme providers will, again, be able to give you the updates. So have a chat with your scheme provider and let them know exactly what your question is. They will tell you what there is a requirement to do or not do. CPD is a big thing. I'll tell you now, this is a big part of what you're doing tonight. Listen to us, this is CPD as well.
But just to say, it has been possible for the last 6 months to take the exam on the Blue Book. But as of tonight, you will not be able to sit an exam on the Blue Book. If you go into an 18th edition exam as of tonight, you will have to be doing it to the Brown Book, carrying the Brown Book, referring to the Brown Book. So don't try and study to the Blue Book any longer.
Yeah, right. Shall we move on? We'll start to have a look at some of the other requirements that are here. So looking at the other requirements then, let's get ourselves into part one. Now, part one looks at the scope of our regulations, and there is probably one change here, a welcome change, I'll say, that really sees the scope of the regulations increased to include a different cable type. So this is where fibre optic has been included, Mark, isn't it?
That's right. Fibre optic's been included for the first time, and you'll also see a reference, two references actually, in Appendix 1. Appendix 1 is where all the British standards that are cited in BS 7671, you'll find the information in there, which standard and which version of the standard. So yes, for the first time, fibre optic cables, because it says fibre optic cables and then optical fibre cables. So there's a bit of a...
I mean, the message is it's any cable, isn't
basically.
it? Because we're talking about premature collapse.
That's right.
And so that's the danger of, we know it goes back to a historic incident where firefighters lost their lives because of premature collapse of cables, and so they've now included any cable which could cause that hazard to a firefighter.
That's right. That's right. So that's the inclusion. That's the change. So
it's a welcome change without a doubt, because I think a lot of times we were seeing installations where we had to go via one set of standards, yet we were seeing somebody else do it completely. And I mean, a cable's a cable. If you're going to get entangled, it doesn't matter whether it carries fibre optic, data, telecoms, signal, whatever, it's a cable, and that's the big thing.
That's right. A number of people think that because they're using extra low voltage, i.e. there could be CCTV installer, it could be data.
Yes.
But just because they are, they'd be classed as band 1 circuits. They're up to 50 volts AC, 120 volts DC, and then band 2 is above that. So if you're installing band 1 circuits, it doesn't mean they're excluded from the requirements of 7671. They're certainly in the scope.
Yeah. So that's the big change here. So we see changes to our regulations, and they happen because of innovation or because of circumstance. Clearly, this is circumstance. We don't want something to happen again. So we're now seeing our regulations change to confirm that hopefully that change will have an effect within our design, within our installation, so that we don't have any of those instances happen again. That's what we're all trying to do, is to make people safer in the installations that they're using. Now, into part 2 then. Let's have a look at part 2. Part 2 is going to look at the definitions.
Now we've got AFDDs popped in there, which we're going to talk about a bit later on.
Consumer units have changed. Consumer units aren't just a consumer unit anymore. And I think the reason here is, working with the manufacturers like we do, Dave, we see now lots more bits go in there. It's no longer just a box for protective devices. Right. It's got lots in there, isn't it?
Well, it sort of also looks ahead to part 8 and the whole business of prosumer installations. So I think it's going to need to be more of a controller for the house, isn't it, than just a
without doubt. Yeah. So let's take a look, because there's not much there, but let's move into part 3. And part 3 is a meaty one, isn't it?
Well, Jake Green's asked for a lot on part 3.
But really?
I think I know why he's asked for a lot on part 3.
Because he's got nothing else to do.
Yeah. He sits at home and he's learning the regs,
page by
rote,
page.
Page by page, and he's up to part 3 because he had to learn to read first. So we're not doing much on part 3 actually, Jake. So you can
thank you very much, Jake, for typing in. Yes, we appreciate that.
Marek will be coming on to you in part 4. He's done a question about SPDs. We'll do that in part 4.
Yeah, great. Okay, so part 3, again, nothing really there, but Dave told us to move on to part 4, so we shall do. So looking here at part 4, there is quite a lot to consider here. Within part 4, AFDDs. It's one of the ones that's in there. Now, AFDDs was in before, wasn't it, Mark? Whereas now we're seeing one word inserted that says shall.
That's it.
So we must be using AFDDs. But only in certain circumstances we should be using these AFDDs. Not everywhere, on certain circuits and in certain building types. Is that right?
That's right. So we conventionally we're looking at higher risk buildings. So HRRB has been included, high risk residential buildings. And what's really been referred to there are these buildings which are 18 metres and above, or more than six floors.
Story, yeah. Six or more floors, yeah.
So where you've got residential buildings of that nature fall into that category, then you'll need to install AFDDs on socket outlet circuits.
Yeah, so this is, if you're going to be working, tomorrow you're going to work on an installation that has got a socket up to 32 amps and it's being fed by a ring or a radial. If you're going to go work on that, then you're going to have to install an AFDD in that high-rise risk or high-risk residential building. So up to 18 metres or above, or 6th story and above. There are some other ones.
Yeah.
HMOs,
Yeah.
houses multiple occupancy. Again, you'll know if you're working in one of them.
Purpose-built student accommodation.
It's going to be in there. Or care homes. So
registered with the Care Quality Commission.
Yeah,
Any of those 4 categories, you will be fitting them over 18 metres or more than 6 stories on final circuits, ring or radial, providing sockets up to 32 amps.
Yes, so AFDDs, if you can't fit an AFDD into a consuming or distribution board that you're working in one of these 4 indents that the reg says, then you're going to have to look at a solution that would allow you to fit it maybe external to the existing and put it in there. But how you'd put it in is entirely down to you as designers, but you've got to put it in ultimately.
One of the myths with AFDDs that was circulated was that the theory that AFDDs wouldn't work on ring final circuits, and if there was a break in the loop, for instance, on the line conductor, if there was a break in the loop, it wouldn't. The theory was it wouldn't see an arc on that circuit
because the current and power would go around the other way, wouldn't they?
Well, you see, an AFDD works. It looks for the arc. Now, when you've got a break in a loop, you've got that line conductor that's separated. The supply can go either way, can't it?
Yeah.
But when there's a break there, you'll only get an arc when there's a potential difference. And because those 2 line conductors, if you like, are at the same potential, they're therefore unlikely to be an arc there. So they do work on ring final circuits. They're just not intended to pick up on a broken loop, on a broken leg. Yeah.
Another thing with these AFDDs, which Dave and I have done in the past, is looking at the amount of energy that is needed. Now, you'll notice they're only at the minute being asked for on anything supplying a socket outlet. That's because there's generally not enough energy in a lot of the other circuits, isn't there?
Lighting circuit or whatever. I mean, the thing to remember about the AFDD is it's not really designed to pick up problems in the installation wiring as such. Yes, if there's a screw loose in the terminal and there's a spark, an arc there, it might. But what it's looking for is anything plugged in.
Crushed cables.
Appliances that may be less than perfect inside, causing sparking and arcing. These are the things which it's really designed to be checking for. Your fixed installation wiring is not really going to develop an arc in the normal circumstances, apart from rodents, maybe a bit of nibbling.
Yeah, in those installations, so maybe thatched buildings, it might be something good, which is probably why we're seeing the other part of the regulation, because you carry on reading, and through reading down, you can actually see that it's recommended for all other installations where there is socket outlets up to 32 amps. So again, in those other, it's recommended. Now, the regs are clear here. Shalls, we should be doing. Recommended, it's there for our information as designers, isn't it, Mark?
That's right. So shall is an absolute definite. It's mandatory to comply with the standard.
The thing is, this device picks up a fault which nothing else will pick up.
Yeah,
it's very common in America. Arc fault, the circuit interrupters, they were called there. And in Germany, they're being used widely. Anywhere where there were buildings made of predominantly wood that were flammable. So they've been very successfully tested out. And you'll find it hard to find too many people saying they don't work very well. They're very rigorous in self-testing, aren't they?
Yeah, you don't need to test them.
They need multiple parameters of fault before they'll trip. So they're not really a fault device that's going to give you any sort of problems once they're installed. So why wouldn't you if they protect you against a potential fire?
There are great merits in installing them. Yeah, without a doubt, there are great merits in installing those devices, as we've seen before. And many of the manufacturers can relate to that as well.
A question that's been asked several times, and it's just popped in, so let's do it while we're here. During an EICR on an HMO, how would you code the socket circuits out without an AFDD?
Okay, so you've gone into the installations where they're being asked for at the moment, but it wasn't done to a previous version. Remember that when you do an EICR, you are not there to say that the installation complies with the current version of the regulations. That's not your job. Your job is to say that it's safe for continued use. And what we have seen is you guys here at the IT and lots of other people have been coming together to work on a document that comes out of electrical safety first. And this is a full list of what you'd expect to see as a C1, C2 and C3. And in there, in the drafts that are coming out, we believe it's sitting there as a C3 for those. Again, it's improvement recommended. It doesn't affect the outcome of the EICR unless there are other components in there that require a higher grading. But just on its own, it would be a C3 and it would be a satisfactory outcome. But it's all about the installation is safe for continued use. It's not, does it comply with the current regulations?
Darren Beagley's saying that the note in BS 7671 is different from the on-site guide as to where you fit AFDDs. What's he referring to there?
You've caught me on the hop there, Dave.
Yeah, I'm trying to think what he means. Darren, we need more information on that because I can't actually think what you're referring to in that question.
I think the on-site guide goes into a bit more detail.
But they're not out of alignment, are they? I mean, the specifications to where they fit is the same.
Yeah, I wouldn't have said so.
Yeah,
Give us a bit more on that, Darren, if you can, and we'll try and get back to you. The question about the ICR was from Giuseppe. Thank you very much to Giuseppe.
Now, we need to just move on. So AFDDs.
No, actually, we should mention what Jeff Smith just asked about. He says, why are we fitting RCDs? Surely that's why we fit them, so the two are doing the same job. And they absolutely do not do the same job, and that's the very point.
Yeah, they are. So if you're looking for a complete installation or complete safety, you can go AFDDs, RCBOs, and again, it gives you the over current and it gives you the short circuit current and the fault current all within the one device.
It won't pick up a parallel arc.
No, it won't. That sort of serial arc is what we're talking about here, where it's a fault in one conductor. All the other protected devices we've got there need a fault current to interact with another circuit conductor or earth. So that's where you get the bits and bobs happening.
They make up the triangle really, because we've got overcurrent protection now, we've got fault protection, and now this is giving us the arc protection. So they do have a separate role to play.
I think the angle there could be that in 705, which is agricultural horticultural, there's a reference there, isn't there, or a requirement to install a 300 milliamp RCD, which can be used for fire protection
as well.
And it is looking, but it wouldn't pick up on faults between live conductors. No.
Yeah, so I wanted to move on and talk about SPDs, because our SPDs have gone from a hell of a lot of regulations down to not so many regulations. However, I must really stress here that it doesn't mean that the requirement to fit SPDs is reduced. It just means that the regulations have been streamlined, doesn't it, Mark?
Yes, it's they were amended to make it easier. You see, what was in, if you remember, in the 18th edition, there was the maps of the UK showing the...
How could I forget?
The pages of showing the flash density.
And don't forget the calculation as well.
The calculation.
Cables,
the calculation was taken from EN 62305, and the whole concept was that you would assess whether SPDs required. That was taken out, and the approach was from the point of view if there's a particular risk there. If an overvoltage can damage circuits, for instance, circuits where you've got banking financial transactions going on, you're going to lose data, risk of life, loss of life.
Or safety services is the third indent there. So again, with safety services, risk of losing financial or data and stuff like that, that's another risk that you've got to consider. And then the risk or injury to human life, isn't it? Saying it's there for that one. But it does go on to talk about understanding this tolerable side of things, because it's not just about you only need to do it in them 3 bullet points. You need to consider in all the other environments that we work, is it tolerable for that over voltage to have an effect upon the installation?
And at that point, that's what it does say in BS 7671, is that if the owner of the installation chooses not to go down the route of having them installed, that becomes their choice.
They're considering it tolerable, aren't they?
That's right.
We need to stress they're not mandatory. Marek says, is SPD mandatory when we add one additional circuit to a present installation? So it's absolutely not the case that they're mandatory. There are certain conditions which will require them, and in other terms, it's tolerable. If it's tolerable for the homeowner to not have that protection, then you can leave them out.
Yeah, that's a good point to pick up on there. Yeah. Also within part 4, there's the requirement to give socket outlets additional protection. So we have to give additional protection to socket outlets that are generally being used for certain things. That's in the blue. When you look now at the brown, we have to apply a slightly different logic, don't we, Mark?
Yes, the approach has changed ever so slightly, and there are categories of persons that are referenced within that particular regulation. And really, it's about the type of person who will use that circuit.
Yeah. So I notice in there that it refers out to a table which we see in Appendix 5, and it looks at children in certain circumstances. It looks at disabled people and ordinary people. So if there's a socket outlet that's going to be used by those categories of people, it's telling us the shall word returns again, doesn't it? We shall give 30 milliamp protection to those. Now, in the past, Dave, we've been allowed to do risk assessment and we've been allowed to put label on. But that label went, and now we're actually starting to see that the only one is a risk assessment. But you can't, again, you've reduced the risk assessment, haven't you, Mark? You can't really go using that in the areas where there's children, ordinary people.
That's right.
Or the other one there. So it really is,
Disabled, yeah.
Again, reducing it so that a risk assessment can only really be used in very specific circumstances.
Yeah. Jumping about a bit, boys, but Gary Taylor said, do I need to fit an AFDD on a cooker circuit with a socket outlet on the cooker switch? Well, you would if that was in one of those designated accommodations, wouldn't you? Because
exactly.
it's a socket, up to 32 amp socket outlet.
Yeah.
Darren Beanie has come back saying, the note in the on-site guy mentions 18 metres or 6-storey, or 2 or more dwellings or 2 or more rooms used for residential purposes. So that's most likely dealing with the house of multiple occupation.
HMOs.
It's another way of wording that, I think, is what you'll find.
It is, yeah.
And there was one more. Surge protective device. Mike Gilbert says that there's a company that's mentioned on the website we should be using AFDDs for car chargers in domestic installations.
Ah, right, car chargers. So AFDDs, I know you're probably looking at socket outlets. Should it be used for socket outlets? There's a little bit here we need to consider. Although it's called a socket and it may be up to 32 amps, it's an electric vehicle charge equipment. So that's the definition of it. So it's a piece of kit, it's a piece of equipment. It comes in a box, it's got lots of other bits in there. So I believe it would move outside of the scope.
Yeah, it's made to a product standard in its own right, isn't it?
Yeah. So again, that's where it does move outside of that scope of socket. So
Zora asks about the ZS for AFDDs. I mean, it wouldn't really be
not just on the AFDD because you can't get it on its own.
No.
So it takes its ZS value from the B curve or C curve of the overcurrent part of the device. Yeah. It's not affected by the others.
ZS. And I think you talked about it while I was looking down this list. Sam Remington says, when is this information coming out in the Best Practice Guide 4? Did you give it time?
No, I didn't tell him when. That's
secret.
That stuff
we know it's coming very, very soon.
We keep being told.
We keep tying Mark down to the table and tickling his feet, but he won't tell us. But it is coming very, very soon. Yeah. And then look for issue 6. So you go to Electrical Safety First, Best Practice Guide 4, issue 6. That's the one that will contain all the codes for the Second Amendment. Yeah,
it's got lots in there for you. Now, while we're in part 4, let's look at one here and let's look at this again. I say again because every single time, and I've been doing regs for quite a while now, we keep looking at bonding, and we're going to look at bonding with you here. Now, bonding, the only real change that's happened here, if you have a look in the blue to the brown mark, there's a bit that mentions a plastic insert, and that's moved, isn't it?
It's moved to a note now.
Yes, right. So what does that mean then?
Conventionally, so you bond where you've got an extraneous conductive part. An extraneous conductive part is that metal part that introduces a potential into the installation that wasn't there originally. So what we really mean is you've got a water or a gas pipe, metallic pipe entering the building, bringing in a potential from outside. So you'd bond that upon entry. Now then, if you had an insert or it came in plastic, there wouldn't be any need to bond that incoming pipe because it's plastic. It's not introducing a potential that wasn't there already. However, and I have this problem in my house because it's an old building, that if you have radiator pipes, for instance, that disappear into the floor and pop up elsewhere, if you know that floor is it doesn't have a damp course in it, you are really those pipes then become extraneous at that point, so they would require bonding.
I believe this change is all about you.
It's all about you, isn't it?
It's all about you.
So using the British standard to cover a little issue at home.
And we'll come on to more of that later on because someone else has got an issue.
Can we whiz back to AFDDs one more time? John Arnold says, should timber frame houses have AFDDs on all circuits? Back to the point, really, which is they are recommended on any circuits where you think they'll be useful. So, if it's a timber frame house, if it's a wooden construction, if it's flammable, it's not a bad idea.
That's where the change occurred, wasn't it? Originally with FDDs that came in, they were recommended in all of these areas, and they were at the time the regulation was focusing on the type of building and the risk, the fire risk of those buildings. However, since, you know, in a world post-Grenfell, the discussions that went on beyond that or after that, it became apparent essentially it's about the evacuation, about getting people out of those buildings, and that's why it's more reflective of the use of the building rather than the style or the type of construction of the building.
Yeah, where lots of people are going to be, isn't it? Where they're going to have to get together to get out of these buildings safely. So that's where.
But to reiterate, those 4 categories are a shall, and then it follows with a recommendation for any other circuits where you feel they could be of use. So I think timber frame buildings is a good argument for that,
Now I'd like to move on and start to look at part 5 with you, because part 5 has got some changes in here, and part 4 looks at do you need to protect, and then part 5 looks at how we should be installing, how we should be protecting, how we should be putting our installations together. And one of the big ones here is around RCDs. So there's quite a lot in part 5 about RCDs, and one of them is around the type of RCD. It used to say in there for general installations we could select a type AC. Now it doesn't say that at all. In fact, it says an AC must only be used where there are loads, fixed loads with no DC components in there.
Essentially, on those type of circuits, if you do want to continue, or you do want to continue installing AC RCDs, you're looking to install them on circuits that are purely resistive. Now, if you think about pure resistive circuits or equipment, you're talking about, I suppose you're talking older fashioned shower circuits,
an electric cooker maybe,
yes,
or electric
an immersion heater,
electrical heater.
But then of course you find that might still be the technology within, but the controlling technology where you've got electronic circuitry and boards, etc., and even power supply systems within. This is where
it's all about anything
yes,
that could generate a DC component that could potentially blind the coil. That's what this is all about. So it's got to be something that you are not getting a DC component or any functional earth.
So the regulation says this. It clearly says that for general installations, it's considered there that now that it's a type A device that we should be using. And we're only really sort of catching up with our continental cousins on Europe, aren't we? Because some of them have been doing it for years.
They've been banned in Germany for quite some time. And I think even in the Netherlands, I heard last week it was 1986 when they were, I think it's Netherlands.
I think we bought all this stock.
But I did pick up last week, we were out at the Alex event last week in Coventry, and we learned that one of the manufacturers has been installing type A RCDs but labelling them as AC.
For the English market. I knew that. Yeah, that was the case, because a type A will do everything that an AC will plus a little bit more, and then site-wise for a type F that will do a little bit more as well, and then again for a type B where it will do a little bit more as well. And these devices are made so that they will continue to work with the DC there. They don't block or filter any DC. What they'll do is they'll ensure that the device will continue to work. The trouble with this DC is as soon as it gets onto some of these early types, so type AC, that DC can saturate the coil, meaning when we need it to do what we need it to do, it probably won't do it. It won't disconnect within the maximum, which is not guaranteed to operate in the maximum. And I imagine, Dave, you're getting some questions now coming in about RCDs, are you?
We are getting some questions about RCDs. And also, we are. There's a lot of comment about escape routes and
protected escape routes.
Yeah, well, it's a bit of a mixture here. Paul Chapman says 42.2 protected escape routes in Appendix 13. If the cable is enclosed in a fireproof box, can the cables be run in an escape route, and does it need to be officially recognised and inspected?
Well, the point there is you're effectively outside of that protected escape route because you've created a fire compartment of your own, so you're effectively outside of that compartment. Although, yes, you are within maybe a concrete structure that was originally designated that protected escape route. The fact that you've compartmented some part of it off would mean then that you're outside of that protected escape route.
But we must draw this thing between escape routes and protected escape routes. Because an escape route is where we're talking about premature collapse of cables and such, like the escape route from a building, like this room here. There are ways out of this building which are pretty obvious. Protected escape routes are quite different things, aren't they? They're designated that way in the plans, and they're the ones we've got to be really careful about what we put in there.
You'll see them in quite a lot of sports stadia, for example, where they're very bare concrete I was going to say Stalin-esque.
Well, I say dystopian. It's like something
Dystopian,
out
yeah.
of Blade Runner, isn't it?
Yeah.
Dripping water
So what
everywhere.
what you see essentially is, there'll be light fittings. There'll be the
Flickering light fitting normally, isn't it?
Yes, it's just
there might be a fire alarm call point, for example, but the fire alarm system in there might be a light switch. There might be a socket for cleaning purposes, but that's the bare
That's
essentials.
it.
Yeah.
So, effectively, the regulation here, where it starts to look at the requirements of a protected escape route, clearly says those indents there. So you'll have a cable in there to supply equipment for fire. So that'll be a manual call point maybe, or a detector. There'll be a cable in there for general purpose lighting, and then a cable in there for equipment to supply a socket outlet. That's it. So you'll know that. There will be nothing in there that says you get a cable from A to B or nothing going across that protected escape route. It is just purely to service that protected escape route. That is it, nothing more, nothing else. So you can start to get hold of them. One thing I will say is here, you can't really apply this set of regulations to old building stock. It's going to be almost impossible for you to do. But when you get new drawings and you get new plans coming in, and tomorrow morning you're turning up and something's come through the post for you to look at and price up, you then need to start asking the question. If something looks like it might be a protected escape route, then you need to ask the question. If the building designer confirms, yes it is, you need to apply that part of part 4.
Yeah.
You need to apply it, that's it. If not, don't worry about part of that section where it says protected escape route, apply the general part of BS 7671.
We're getting the EICR questions coming in already. So Type A CRCD, protecting sockets with DC appliances plugged in. Type A CRCD with sockets but no DC plugged in. What's the code recommendation for each? That comes from Kenny Cook. Well, that's what's plugged in then, isn't it?
Yeah, you don't look at what is all plugged in. It has the ability to plug in, then it's going to move you towards a C3. If, however, now this is again coming down to engineering judgment. I've had this chat with a couple of designers. Computer rooms in schools.
Yeah.
They used to have an RCD when you went in the front door, and it used to allow the teacher, when they were on their way out, hit the button or trip the switch to make sure everything was off, so no one could mess about with the computers during breaks and bits and bobs. That, if it's a Type A C RCD controlling 30 computers, you could look at that and you could say actually that's a bit more of a problem, because now I know that there is a lot of DC, because effectively they're only plugged in because it's ease. They could be hardwired. They're not going anywhere, are they? So there's all these things that are sitting there.
The truth is, with that much functional earth current, you're likely to get it tripping the whole day.
This is what they've got to consider. So some environments you are going to have to, again, using engineering judgment, you're going to have to switch from that C3, you're going to have to move it up to a C2, which would give you an unsatisfactory outcome and would require you to do something about it. But as the regs stand here now, it's a case of if you're installing, you need to go in and install a new socket outlet to an existing ring final circuit or radial. If it's supplied with an AC type RCD, you probably couldn't do that. You'd have to look at what you're going to have to do back at the origin to protect it with a Type A device.
While we're on RCDs, Stuart Garforth says, read Type B and C RCDs. What are your thoughts? So Type B are lovely.
Yeah, I know what my thoughts are. One thing I think we should say is we do know that there is a direction with RCDs, and the direction is that yes, ACs were okay, now it's to A's. Let's look how A's are doing, and as our installations evolve and become more and more techie, is that going to be okay, or do we need to perhaps look again in the future? So I think this is going to be something that you guys are going to be looking at quite a lot, Mark.
I'm sure we're working with the manufacturers.
He's sitting on the fence. Right, also with these RCDs, there's something around unwanted tripping. So how to minimise that unwanted tripping, because no one wants devices to trip. We just want an installation that works. So here you have to look at 30% of the device rating. If you're choosing devices that are at 30 milliamps, then 30% of 30 milliamps is 9 milliamps. So if it's protecting the final circuits, and there could be current coming back into that device that could be more than 9 milliamps, I couldn't leave it on one RCD, could I?
No, you need to separate the circuit and align with 314, which is the division of an installation.
Yeah. So, and also just above from that, there is a suggestion, Mark, that RCBOs are now recognised fully by the regulations, and that would be an easy method to comply with that.
Of course, yes.
Yeah.
And that really is the definition of 314,
Yeah.
division of the
A
installation.
pure division, isn't it, that one? Yeah. So again, there's that one to consider as well within there.
Sorry, I am jumping you around a bit. The questions are a bit random. Jason Backor says, will plastic conduit require metal strapping to prevent premature collapse? So if something's been fixed in plastic conduit,
Yeah.
it will, won't it?
If you're
It needs
doing,
reinforcing.
yeah, if
With
you're doing
metal
any
saddles
ICR,
or something?
yeah, you can get them. I know lots of people out there, lots of manufacturers that are doing these because they are going in doing the ICRs and finding that there is the opportunity for conduit to collapse, plastic conduit in those environments. So yes, they do. If they're picked up, then yes, you can find them and you can fit them.
Talking about SPDs, which I know we've slightly moved on from, but Andrew Gibson says, do we have to fit a specific type of SPD? This is why I want to talk about it, because it's a very important question. Obviously, there are type 1, 2 and 3, also combinations of those. So we have to really think about this.
Yeah.
There's a very obvious answer to this question, which we have to give. So if there's lightning protection on the building,
It's got to be
a type 1.
It's got to be a type 1, yeah.
But all other buildings without lightning protection, you're fitting a type 2 at the origin, and then depending on the manufacturer, you'll be working through the installation, 10 metres, 12 metres, you should be repeating that type 2.
This is the advice from manufacturers, the way that the overvoltage appears on the circuit, because it attenuates.
It's an attenuator, isn't it?
That's
So it's
right,
dropping
yeah.
it down and then it rises back up again over that 10, 12 metres. So you're now going to knock it back down again. But when you get to the device itself, you're looking for a type 3.
Yeah, then this is all about coordination of these devices. So we need to ensure there is coordination through a manufacturer, and you're working, and I would stress this, if you're looking at pure protection from these over voltages, think really hard about not mixing and matching. So don't go with one manufacturer there and a different manufacturer here and someone else there. Think about a complete solution to ensure there are no gaps, because these gaps are where that overvoltage will find its way into the installation and create its damage. So ensuring that there is coordination of the devices is very important if you're looking for those complete installations. So
And we've not even started to talk about lightning protection zones, which are where you work your way into the building.
Zonal concept,
But if you're doing any size of installation, then call any of the manufacturers that you choose to use, and often they'll come and do an assessment for you. They will give you the information you need. They'll plan the whole thing out for you and tell you what you need to do, because it is quite a complex business, making sure that surge is protected all the way through the building. Yes. Yeah. Just jumping back to Type B and F RCDs, Nigel Charteris says, you mean they were made mandatory in 1990 in Germany? What it meant was ACs were made not mandatory. You couldn't use ACs.
Still banned, yes.
So it wasn't mandatory as to what you did use, it was what you didn't use, which was a Type AC.
Got rid of those ones there. Yeah. So I'd like to move on to looking at part 6, if I may, gentlemen, because in part 6...
I'm going to let you. You can try. Keep going. I'll let you go a bit longer.
Within part 6, there's one big change that I want to talk to Mark about, which is looking at how we test our installations on installation resistance, because that's had a tweak, isn't it, Mark?
It has, and this comes about testing cables which are installed. So you do a first fix stage, you'd install the cables, and then you'll go away and the plasters come in, the carpenters, whatever, do their work, and when you come back, you don't know if the cable's been damaged, a nail's gone through or whatever. You could test at the second fix stage, and it's a bit too late at that point. So the whole concept is that you test the circuitry at first fix stage, but you must test to earth. You must connect it to the means of earthing when you test those cables. And it might be you've got different legs of cables of the circuit installed. You need to connect them together, connect them to earth, and carry out the test at that point, because then that proves your installation resistance is clear to earth. That's the key point.
It's going to cause some problems, because sometimes when you're doing a first fix, there isn't a reference to earth if you haven't got the original, the origin of the installation that's been installed. So that's going to become. Also, manufacturers of our cables are telling us that it's vitally important that we do test at that 500 volt stage. So I get it. Where we haven't been testing, or some of us haven't been testing at 500 volt, is when connected equipment would be damaged at 500 volts. So when we do what we've done in the past, first fix, second fix, and then test, that test could damage some of the components that we've just installed. So what do we do? Or do we go around, take them out, or do we drop it down to 250? And that's the bit that Mark's on about here, is we should never, ever be on an initial verification dropping it down to 250. We should only be doing it at 500 volts.
But the one you record, Dave Hedden says, when we test for installation resistance on new circuits, we test at 500 initially, then at 250 when devices are connected. Which test do we record on the certificate? It's the 500, isn't it? That's the one that matters.
Well, you might
Good question.
you might state that the fact that you've cited 250 volts on the certificate implies that you already did the 500 previously at first fix stage. So if you record 250, that's the implication there. Because you'll find that maybe this is one for the software developers that allow you to put the two voltages in the one box, but at the moment you can select one only. Yeah. But by putting 250 in, implies that you've done five. You've done at first
That's
fix.
the last test you would ever
That's
do.
right. Yes.
Okay. So Dave,
but it is absolutely
answer.
important
Because
that
you know it's initial verification.
you've got to stress.
get that.
You've
Yeah.
got to stress the cables at 500 volts.
You must.
Yes,
Yeah.
that's a key
It's
thing.
never okay to substitute a 500 volt test with 250 on initial verification. If it's EICRs you're doing,
I was just
you
about
do
to say,
periodic-
before the question comes in,
Yeah,
EICRs
you can,
with
yes,
250 because the
different.
equipment's are connected.
Yeah, different.
And there's a lot of the later equipment can actually handle a 500 volt
Can do
test.
now,
So
yeah.
if you look at the spec sheets and the downlighters can handle it, then
Yeah.
you can do the 500 in one hit.
Yeah.
Quick question while we're on cables. Tony Wilcox says, have we now got any specific guidance for meter tails in domestic houses? I.e., is there a max length between the meter and the consumer unit, as is often an issue in refurbishment projects?
Yeah, it used to say in the old set of regulations that it was 3 metres maximum, didn't it? And then it used to say that you can go more than that if you got the permission of the DNO to use their main fuse as the overcurrent protection for the distance you were going to go. Something like that it used to say, didn't it? But
It gets tricky, doesn't it, when you've got to run the meter till some distance, and even
do,
through
but-
walls and
where you're
and
going to
it's-
go with it. Yeah. So no, there's nothing specific around that one. Not from BS 7671 anyway.
no.
And maybe it's something that we will look to challenge with some of them DNOs when we get hold of them, Dave. We'll get hold of
Steve Trott's handing you a sales opportunity on a plate here, Darren, if you want. Table 51, change of DC colours for identification of conductors, that is negative of positive earth, circuit to grey to white. We're struggling to source white sheath for telecom DC power installations.
I'll have a note of that and have a chat with a few people, shall I?
Have a little chat, yeah. Steve Trott, you want to tell him? Absolutely.
yeah.
Mike O'Rourke says SPDs can't be tested at 500 volts.
No, you're right, SPDs.
right.
In fact, if you're doing anything with SPDs, you've got to be looking to either remove them, which you
absolutely.
can with some of them, you
Yeah.
can just pop the modules out.
Yeah.
Or a lot of people are saying the reason they're fed from a protected device before they go to the module is so that you can isolate that device,
Yeah.
then isolating the SPDs from the circuit.
yeah.
That's a really good way of doing it as well.
This change is obviously new to a few of our viewers today because Nigel Charteris says, so if you're adding a circuit, you then test the new cabling at 500 and then the whole installation at 250. Is his first question. So that's a process he's not been doing clearly.
Yeah, so a new circuit, yes, would be initial verification of that new circuit.
And Ian Palmer says,
Yeah.
so does that mean you second fix an installation?
No, you don't go full second fix. You would use either some flow connectors or some Wagos to get you the connecting, to get you the continuity. So you do that, and then you do the actual tests. At that
This
point.
is actually requesting something that was supposed to be done.
Yeah, we've been doing it for years.
And it sort of hasn't been done, and there was a general sense that perhaps it ought to be back again. So this idea of stress testing these cables at 500 volts, the manufacturers want it. That's the reason for this. How you manage that in your particular situation, whether you can manage it in one test or have to do the first 500 and then the second fix and then test again, that's up to you, but it should be done.
If you're selecting equipment that can handle 500 volts, you may think on small installations that you're in control of and you know how people work. First fix, second fix, then test again may be an okay method to use, as long as you're still testing at that 500 volts. You must be stress testing those cables. And again, as Mark said there, on larger jobs, it's always spoken about to test as you're going very clearly on that.
Okay, we're halting at the moment. There's one question that hasn't fitted any of our subjects. I can ask it while we've got a slight pause.
Does it fit in part 7?
Well, it doesn't really fit any. Well, I suppose it might fit in part 8, arguably, because it's about. Let's do it in part 8.
Okay, well, while he's doing it in part 8, let's move on and start to talk about part 7. Part 7 looks at special installations and locations. And in doing so, it always starts off in 701 looking at rooms containing a bath or a shower. Yeah. And there has been a change here. That is a welcome change in the Austin household.
Yeah, it's just because when I did my installation, there was 2.75 metres from the edge of the bath to where I wanted to put a socket. And we love having a socket in the bathroom because we listen to the radio and stuff. So I decided, as long as it was in a cupboard, it would be okay. And I did it. So it was 0.25 of a metre
in a cupboard.
Too close. But it was in a cupboard, so you really had to work hard to get your fingers in
a
there.
cupboard, it's outside the zones. If the
Well,
door closes, you're
You say
outside.
cupboard.
When the door closes, yeah, but when
I'll
the
be
door
quiet.
opens, of course, it isn't. It's in the zone, isn't it? You trip across there. Anyway, the change to down to 2.5 metres from the edge of zone 1 is welcome to me because now I can do any RCR and it performs.
Apart from, what he hasn't told you is his wife has a 3 metre extension lead for the
I had to put
hedgerow.
that on because you can get the header on the bar. But that was the point, that the distance from the edge of zone 1 now, a socket can be installed at 2.5 metres.
That's what they're saying on that one there.
yeah.
There is another change here, and this is a really serious one. This comes from a circumstance that we definitely don't want to happen again. There was a really unfortunate incident that happened in a pub car park where a child was playing and was connected to some external lighting that was live. And unfortunately, we lost that child at that instance. So what it's in now is the change to the regulations now means any external lighting must have protection with 30 milliamp hour CDs. So that's a really important change.
Yeah. The question I referred to, by the way, it would fit around 712, and it was to do with Lukas Makowski says, is it now a requirement when solar panels are fitted, the current rating of the main switch needs to increase to 125 amps on domestic installations?
You ain't going to get it.
No. But is it a requirement? Where's he picked that up from?
No, I think he's getting 1.25 from the standard, and that's what he's looking at. One thing I will say is section 712, that's got a lot in it, mate.
Yes, it was updated to the HD 603647712 from 2016, and it's one of those fast-moving industries, isn't it?
Yeah,
because
massively.
and not just from PV, but what PV connects to. Because there's talk of vehicle to grid.
Yeah.
We'll get on to prosuming installations, but there's all of that to consider.
Batteries.
And also to export. If you're exporting, the voltage needs to be higher than what's to export. So it's
We spent this afternoon preparing for the next series of Tech Talks, and we're trying to deal with this topic. And I can agree with you; it's pretty hairy, isn't it?
It's
There's
mammoth,
a lot
I
to
think,
think
yeah,
about.
It's
a lot
mammoth.
to think
So
about.
yeah, so in there, currently, if you look through the wording, it is really hard to get your head around. So we appreciate that. We're going to do more, definitely at CEF, and the guys are coming with us from the IET when we do our next round of Tech Talks, so we're going to try and bring you those. In fact, there's one coming up next week, so on the 6th, if you're in around the Sheffield area, you want to know about PV, EV and stuff like that, Mark and the team are going to come and join us, so if you wanted to know about it, you can do from CEF Tech
Actually,
Talks.
if you know about PV and EV, come along and help us with it. It's going to be hell.
We'll get there, we'll have it.
Just back to the RCD on lights, the comments come in, surely 30 milliamp RCD has always been necessary for external electrics, but not on lighting circuits.
Yeah, so if you're looking specifically into Part 7, it wasn't there. It is now. It's clearly saying that it is in Part 7, and it's considered that type of installation is considered high risk because of the environmental conditions. It's getting blown. It's got a lot of rain on it. It's sat there for ages.
Yeah.
It's in direct sunlight. All those conditions. Plus, the general public don't look after things, do they? So it can be vandalised.
yeah, that's right. It certainly makes sense, doesn't it?
Yeah, so we can see that welcome change there.
Yeah, absolutely. Part 8 then, are we on to Part 8?
Let's do Part 8.
Let's do Part 8. So the new part that we thought was coming on the 18th edition, that didn't materialise, did it? We were all excited about it.
You're talking about energy efficiency, which
energy
became
efficiency, but you
appendix.
love this one, don't you?
There's a place for everything and everything in its place. I think with energy efficiency, if the client wants it, Appendix 17 is the way to work. It's the framework to work to. So, for instance, if the big building's got a transformer, have the transformer located as centrally as possible, so that you're moving out from the main switch point area. Rather than having everything at one side and you've got to run long sub-main cables, and every long circuit, of course, there's a loss to it. There's a loss to every electrical circuit and installation, but long runs, there's lots of losses. And these cables get warm across, and all that heat created is a loss of energy. So energy efficiency, it's a good framework to work to should the client want it, and keep everything as short as possible, essentially. And there is some merit to having larger size conductors, because larger size conductors means less losses, they're not getting as warm. So over time, there is the argument, the position that you would save money over time.
Yeah, you tell that's the client.
That's
the
I mean,
argument,
look
isn't
at the cost of energy at the moment. That's
now
topical, is it not?
Yeah, you start to look at it. Another thing that we need to talk about is the new stuff that we're seeing in now when it comes to looking at that Part 8. And Part 8 now, as we see it, or 8.2 as it sits there.
Chapter 82,
Yeah, it really is something new that we need to just get a head around. At the moment, it is quite conceptual, but there is a framework which to work to, isn't there?
Indeed.
Yeah, I mean, the concept of this prosumer electrical installation, the PEI, we're sort of there, aren't we? People are doing that already. It's not the future, but there's a bigger concept of the idea of grouping these things, collective. So just give us that.
There is. So prosumer, again, prosumer, you're producing and consuming, and that's where the word prosumer comes from. So you produce where you might have PV, and you consume. That's where that's where it comes from. But you could be you could operate in island mode in your own dwelling. So, for example, at the moment, if the utility supply in the neighbourhood is lost, your PV is meant to shut down and not export, because you could then be supplying the whole neighbourhood. You wouldn't get very far, but that's what could happen. But with islanding mode, which is adhered to in Chapter 82, island mode means that you could be off grid. You just supply yourself, but you could be island mode with a small cluster of dwellings within your area. I mean, we're familiar with, for instance, a new housing estate's gone up, and you'll see a compound or a shed or something like that. A bit more glorified than shed. But that's where the transformer for the area might be housed. But we would see a building like that, which would have batteries for battery storage, for instance. And with that, it's a cluster, a collection of houses that could all of them would charge that battery storage, and then at times when they want to use it, they would use that battery storage, and they'd be metered. So presuming it could be a single dwelling, it could be a cluster of dwellings.
And all of this is being controlled by a new entity we're learning about called the distribution system operator.
Yes.
Because you've now got the current flowing in both directions. You're generating it, you're consuming it.
Yeah.
And so somebody's got to manage all that.
We're going to see that more. We refer to DNOs, don't we, at the moment? But DNO, let's say the DNO is analog and DSO is digital. That's one way of looking at it. DNO is old school, but every DNO, my understanding is that every DNO will become a DSO, because they need to manage and balance the systems.
Now, if people are sitting and listening to this saying, this is miles away, I don't have to worry about it now, actually, yes, you do. We have been onto those DNOs, and we are seeing a hell of a lot of information already available about becoming prosumer installations.
Absolutely.
I mean, believe it might not be the odd one and two, it may be where a developer has said, right, I've got a new 40 plot, it's going to start to do a development, and they'll say, right, you will be the part of prosumer installation, all of it, and that's where they'll start to pick up these. And then again, where small developments turn into large developments, again, this is where some of the concerns of Mark said, because islanding mode means a reference to Earth of your own, and then when you switch back, maybe in the winter months, to start to draw energy from the network, you need to have a reference to the grid. So this is where we're seeing changes in there.
Well, I mean, so much so that 7430, the standard on earthing, is having to be reconsidered, isn't it? Because there's so many changes now about the way that we handle the Earth situation.
Yeah.
So that's all something but being looked into, and we can't really even talk about that at the point because we don't really know.
Something else that we are seeing is there's a mention in there about overcurrent protected devices, because typically we have always, it's been indoctrinated into, we must make sure that the devices at the origin of a system are quite large, and it gets smaller and smaller and smaller as it goes towards the piece of equipment that we're looking to protect. Now, if that piece of equipment would be something like a battery charger or a battery that sits there that's going to chuck back into the installation, my coordination of devices is round the wrong way when it starts to give energy out. So we need to look and consider our design and how these protected devices should work in coordination with each other. So we need to look at that. Also, bi-directional devices. These are something that we're going to have to consider here, because it mentions in Part 8, it mentions vehicle to grid. And again, that would look for energy flowing in a completely different direction to what we expect it to flow. So this is allowing for devices to not have an input and an output, because that will be compromised when the energy looks to flow the other way. that's where we've got to start to look at these installations.
Yeah, the whole vehicle to grid thing could become enormous. Once we get a large national fleet of electric vehicles all plugged onto their charging points at night, that could become a national battery resource, couldn't it? Which has to be managed by the DSO.
I've certainly had discussions about the term upstream and downstream, and in this concept, how do you describe? And
It depends when, doesn't it? It depends
where's
when.
the origin?
Yeah, it depends when that is going to happen.
I'm just going to pull us back to something because I don't want to leave any threads hanging. Remember Lucas's question about the 125 amps on the main switch, and you said, "Well, good luck." Apparently, Andrew Brown.
Oh, on the main switch? I thought you meant main fuse.
No, the main switch.
Right.
So Andrew Brown has come in and said it's about the INA rating of the consumer unit at 100 amps. If you add a solar or battery, it increases the load.
Yeah, it's the consumer.
That was something apparently Hager were talking about this morning.
Yeah.
So that's why it's coming out.
Sorry, my fault. I thought he meant the main fuse. Yeah, you aren't going to get that up. But yes, I agree. Yes, if you're going to look to disconnect that because of that potential load requirement, yes,
Okay. Super. Right. Have we done part 8 enough?
Yes.
Yeah,
I just wanted to talk about HDs and the occasions when BS 7671 has changed. So we see an amendment, and amendments really mop up, if you like, the changes to HDs. HDs are harmonised documents. So if you look in BS 7671, I'm going to say round about page 12, I'm possibly wrong with that, but it's around, but it's the early pages anyway. It cites all the HDs which BS 7671 is based on. Now, harmonised documents are issued in the European region and for CENELEC countries. We are a CENELEC country because our national standards body, BSI, is a member of CENELEC. They therefore are copyright holders of that information in the UK, and we implement that in BS 7671. Now, BS 7671, of course, we conventionally amend it every 3.5 to 4 years. And the reason really that is when HDs are published, the UK, all countries, all members, CENELEC member countries, have 3 years to implement those changes. And implement the change means they publish that information and they delete or remove any conflicting standards. Now then, if an HD lands outside of our amendment period, then that is published as a BS HD in the UK. And even though it's not incorporated in BS 7671, we still have to be taking that into account. Now, you think about Germany, for instance. Germany, they have all the different parts that we know in one book. They buy all the different parts separately.
I'll price this up.
Yeah.
So I've had a look at this. So our regulations, they come in one document, we pay one price, we've got them all. If I wanted just the harmonised documents on 701, working in rooms containing a bath or shower, €90 for just that one section.
But then that section allows you to, it has the bare essentials.
Yeah, only has it, yeah.
But that's the changes because it supplements or modifies. Part 7 supplements the main route.
We worked out that to buy the regs book in 2018 would have cost about €4,500 if you did it that way.
Euros.
Yeah. €4,500.
Euros, if you're going into euros, yeah. So,
which is the same thing now.
Isn't it?
As we speak.
Yeah, it's like for like, isn't it? We'll leave you with one little bit of happy news here, and that is a reduction in workload for us Sparkies that are going out there and doing all these installations and filling out all this work. Model forms have changed, haven't they, Mark? And they've changed because we don't want them spending too much time ticking boxes.
Yes, that box ticking exercise. So in the schedule of inspections on the EIC, we've seen a reduction in the number of boxes, and it's gone down to 14 from, I think you had
228.
Yeah,
228.
That was your assessment.
Covers the same stuff, doesn't it?
Does.
Because it groups it down. And,
That's right. The fact that you tick one box means that you would have ticked a lot previously. So we're saving ink overall.
But worth mentioning, though, that if you generate your own model forms, you must make sure that they are still up to date because the model forms have changed in the Second Amendment. So not dramatically sometimes, but enough worth checking.
Yeah, please have a look at that bit there. So we're done.
Intro,
part 1, part 2, part 3, part 4, part 6, and 8, and then finished off with some mention about the appendix.
We got one more. Just Kenny Cook just squeezed one more question in. UPS batteries in house. Say you're on a UPS source and this increases your disk times massively.
Yeah.
Would this mean that in principle RCD may be needed for everything for fault protection?
Now then, if your disconnection time increases, and you will not miss the disconnection time, the requirement is that the output of that source has got to reduce to 50 volts AC or below in the required disconnection time.
Right.
So the fact that you're increasing the disconnection time makes it easier to comply.
So the fact that, I think what's implied there by Kenny is that if there is an increase in disconnection time, then you're therefore not meeting the disconnection time under a particular fault,
It's easier to comply.
then you're not meeting BS 7671. But the source has to reduce its output to 50 volts or below within that required disconnection time.
That's the thing with the UPS, is about making sure that it does drop down to that 50 volts within that maximum period.
And that, yes, and it does say UPS, doesn't it?
Yeah, that's the thing. You need to look at what output you're going to get after a certain time. It may not switch off completely, but yeah, you do have to just consider that.
Brilliant. Well, thanks for all your questions. There's some really good stuff coming in there. Thank you very much for moving us along. And I think we've pretty much done it.
Yeah, so if you want to know a little bit more about how changes to BS 7430, which is the earthing standard, changes to EV, changes to PV systems and electricity work regulations.
Yeah, we're even going to take a quick peep at duty holder responsibilities and what you have to do to comply with the Electricity at Work Regulations 89. So it's going to be a pretty packed morning on these tech talks, and we start next week in Sheffield.
And we're going to be looking at EICR coding. So all your questions that we've got tonight, we're going to look at them again with you guys.
So we've got
go
issue
through them
6 by
again,
then.
and we're just going to keep going and going and going until we get it right. So
Yeah.
this is another opportunity to come and see the amazing team that we've got here with the help of IT. And
You're going to be with us, aren't you, in Sheffield?
I am, yes,
Yeah,
that's the plan, yes.
Lovely.
So thank you very much for your time this evening. We really do appreciate it, and we'll say wait until next time, because there is going to be a next time. Until then, take care and see you soon.